Welcome to first order linear non-homogeneous equations. So the general idea here is if we have an equation of the form y prime plus p of x times y is equal to f of x. We can't separate the variables. And so what would be really nice is if that left-hand side were a known derivative and therefore easy to integrate. So it would be really helpful if the left-hand side were a known derivative. So for example, if we had sine of x times y prime plus cosine of x times y is equal to tangent of x. Sine of x y prime plus cosine x y, that is just the derivative of sine of x times y. Right? And so we have, apologize there. We have that derivative is equal to tangent of x. And therefore, sine of x times y is just equal to the integral of tangent of x dx. Right? So if that left-hand side is a known derivative coming from the product rule, then we can just integrate both sides easily. So the process, essentially, we are going to force the left-hand side to be a known derivative. To do this, we will use something called an integrating factor. So to do this, we will multiply the entire equation by an integrating factor. Which we will typically call mu of x. So what we'll do here is we will have mu of x times y prime plus mu of x times p of x times y is equal to mu of x times f of x. In order for this left-hand side to be a known derivative, we're going to force the product rule. So the derivative of mu of x times y would be equal to mu of x times y prime plus mu prime of x times y. So what we need, mu of x to satisfy mu prime is equal to mu times p of x. So again, here we have the mu of x y prime already occurs, but that mu prime of x y should match that mu of x p of x y. This now is just a separable equation. And mu of x is just e to the integral of p of x dx. So we would have mu prime over mu equals p of x, integrate both sides, we would have natural log mu equals p integral of p of x. Therefore, it gives us mu of x equals e to the integral of p of x dx. So from here, let's go ahead and just do an example. So let's find the general solution to y prime plus 3 over xy equals 2x minus 1. So this is non-homogeneous. And linear. So what we will do, step 1 is to find the integrating factor. So we have mu of x is equal to e to the integral of p of x dx. In this case, p of x is 3 over x. Right? So the plus 3 over x times y, that 3 over x is our p of x. 2x minus 1 is our f of x in our usual form. So we have mu is equal to e to the integral of 3 over x dx. That means mu is equal to e to the 3 times the natural log of the absolute value of x plus c. This is e to the natural log of the absolute value of x cubed plus c, or c1 times x cubed. So we can pick, we just need one integrating factor. And so we can just pick mu equals x cubed. From here, our step 2 is to multiply by the integrating factor. So we have y prime plus 3 over x y was equal to 2x minus 1. We are going to multiply that entire equation by x cubed. So we have x cubed times y prime plus 3 over x, x cubed times 3 over x would be a 3x squared times y is equal to a I'm actually going to write this part here as x cubed times 2x minus 1. At this point, our next step is to rewrite the left side as the derivative of a product. So that left-hand side is just the derivative of x cubed times y, right? If we product rule that, we would have x cubed y prime plus derivative of x cubed is 3x squared and then times y. So we have the derivative of the product x cubed y is equal to x cubed times 2x minus 1. Then we integrate and solve for y. So we have the integral of the derivative of x cubed y dx is equal to the integral of x cubed times 2x minus 1 dx. That left-hand side is just x cubed y, technically plus a c. Right-hand side, we're looking at the integral of 2x to the 4th minus x cubed dx. So we have x cubed y is equal to 2/5 x to the 5th minus 1/4 x to the 4th plus c. This means, therefore, if we solve for y, we get that y is equal to 2/5 x squared minus 1/4 x plus a c over x cubed. So this is sort of forcing that left-hand side into a product rule situation by using an integrating factor and then solving from there. Just a quick note. In step 1, so if we have, just in general, if we have the general equation, y prime plus p of x times y is equal to f of x, then step 1 would yield that the integrating factor is mu of x equals e to the integral of p of x dx. That's what we saw when we were first looking at integrating factors. Step 2 when we multiply by our integrating factor mu, we have e to the integral of p of x dx multiplying y prime plus p of x y equals f of x. This becomes e to the integral of p of x dx times y prime plus e to the integral of p of x dx times p of x times y is equal to e to the integral of p of x dx times f of x. When we go to do our step 3 and force the product rule, e to the integral of p of x dx times p of x is just the derivative of e to the integral of p of x dx. And so we just have, this is the left-hand side is the derivative of e to the integral of p of x dx times y. And then on the right-hand side, we have e to the integral of p of x dx times f of x. Or the left-hand side is just the derivative of mu of x times y. And the right-hand side is just mu of x times f of x. In our step 4, if we integrate and solve for y, then we have the integral of the derivative of mu of x times y dx is equal to the integral of mu of x times f of x dx. So we get on the left-hand side, mu of x times y is equal to, on the right-hand side, the integral of mu of x times f of x dx. And therefore we get that y is equal to 1 over mu of x times the integral of mu of x f of x dx. So I just redid the 4 steps from the previous problem using a general equation instead of a specific one. And we get a very simple formula for our solution. So here, mu of x again was e to the integral of p of x dx. So we get a quick solution here. We don't actually have to walk through all of the steps to get there. So if we find our integrating factor, we can then very quickly find our, once we find our integrating factor, we can very quickly find our equation or our solution. So in the next video, we will do one more example where we just jump straight to this formula.